let's look at the positive sequence and negative sequence. Here in this course, of course, we only introduce the concept. The reason for introducing this concept in the practical world, because the actual system, you may not always have balanced system. So if you have unbalanced system, the source voltage is unbalanced, and then you can break them into two sets of balances, the sources. One is a positive sequence, the other one is a negative sequence. Sometimes you also have a zero sequence. So we're not going that much detail. But for the concept purpose, we need to introduce the positive sequence. Most of the time we have a positive sequence. Positive sequence means if we have the phase voltage VAN, VBN, and VCN, they form a positive sequence if A phase is leading B phase, or B phase is lagging A phase, and then the C phase is lagging B phase, right? So that's form the positive sequence. And if you draw the Phasor diagram, typically let's see if VAN is here, and VBN going to be here, and VCN. So they form in the clockwise direction, right? So if we go from VCN, and so you go here, and you go kind of travel clockwise direction. That's the positive sequence, okay? And it kind of intuitive makes sense, right? So clockwise direction, that's the positive sequence. And let's see, do a quick example on these. And so for the positive sequence, let's see, I have VAN is given, and then I find VBN and VCN and VA, and also the line-to-line voltages, VAB, VCA, VBC, okay? And actually, since VAN has a zero phase angle, right? So I have the VAN drawn here, so this actually matches the VAN phasor exactly. So this has zero phase angle, so VBN is going to be lagging VAN by 120 degrees. So I'm going to write out the result, and that's going to be negative 120 degrees, right? And of course it is a volt RMS value, and VCN is going to be equal the same magnitude, and you could write negative 240, right? Because VCN is lagging VBN by 120, or you can write it just to see positive 120, right? So the VCN is leading VAN based on the Phasor diagram, leading VAN by 120 degrees. So this is the. And now I need to calculate the VAB, right? So the VAB, if you do the Phasor diagram, the VAB is VAN minus VB, that's equal VAN minus VBN. If you still remember how we do the two phasors, the subtraction, right? So that's going to be the phasor from the VBN pointed to VAN, right? And if you apply the geometry here, so this is 30 degrees, this is 30 degrees, right? So let's see, here, this is 90 degrees. So the half of this VAB magnitude is equal to square root 3 over 2. So therefore, this is going to be equal 4160 times square root 3 times the angle here is, so I can move this phasor here to here, so this is the same, so this is going to be 30 degrees, so therefore VAB would be 30 degrees, right? So you don't have to use a calculator. If you want to use a calculator, that's fine. You can just use VAB, VAN minus VBN, and then convert to the polar form. So that will definitely work. But if you use a Phasor diagram, this everything really simple, and there's almost impossible to make any mistake here. Okay, and VBC is going to be equal VBN minus VCN, and VBN minus VCN, that's the phasor here. So therefore, that's going to be equal 4160 times square root 3 and a negative 90 degrees. And volt RMS and VCA is going to be equal VCN minus VBN. VCN minus VAN. And here that's going to be the phasor. That's going to be the phasor points to VCN. Right. So therefore, so this is the VCA, and so therefore that's the this should have 150 degrees, right? So that's going to be equal for 160 and 150 degrees. Look at these angles, right? So the VBC lags VAB by 120 degrees, and the VCA lags VBC by another 120 degrees, because negative 210 degrees is the same as positive 150 degrees, right? You can always add 360 with the same phase angle. Okay, so these are the positive sequence. The negative sequence is kind of the opposite, right? So the negative sequence is, let's see if we have the voltage, they form a negative sequence if the A phase is lagging B phase by 120 and the B phase is lagging C phase by 120. Or you can see the B phase is leading A phase by 120 and C phase is leading B phase by 120 degrees. Right, so that's the negative sequence. And by the way, both negative sequence and the positive sequence, they are balanced, right? So they're separated by 120, they have same magnitude. And so if you draw the phasor diagram, let's see if you have VAB, VAN, and now instead of being VBN, now is VCN now, because VCN is the leading, VCA is lagging VAN by 120, or VAN is leading VCN by 120, right? So this is the VBN. And if you travel this to the three-phase from A to B to C, you are traveling counterclockwise direction. So therefore, this is the negative sequence. And in the power system, we typically majority of the time we only have the positive sequence. If the system is unbalanced, we're going to have a negative sequence. So for this academic exercise, so I give you only the negative sequence when you know how to calculate this. Okay, so let's see if we have a negative sequence. If we have VAN given, so we know the VBN is going to be, instead of lagging, and they're going to be leading VAN by 120, right? So that's going to be equal VAN times E2J 120 degrees. That's going to be equal to 277, and the angle going to be equal 90 degrees. So negative 30 plus 120 degrees, that's 90 degrees. And VCN is going to be leading VBN by 120, right? So that's VBN times E2J 120. So instead of having 210 degrees, we see we have a negative 150 degrees, 277, the same magnitude, and that's negative 150 degrees. Because of the E2J 210 degrees, the same as E2J negative 150 degrees, right? So let's draw the phasor diagram and see if we can use that information to assist our calculations. So I have VAN here. So VAN has negative 30 degrees here. So I'm drawing roughly to the scale. And the relative position of so I have VAN, and VCN is, I have VBN here, right? So VBN is 90 degrees and VAN is negative 30, and so this should be 120 degrees, right? So 90 degrees and negative 150, which is positive 210. So 210 and 90, that's 120. So these are the phase angles. These are the phasors. And therefore we have VAB, and that's equal VAN minus VBN, right? So if I do draw the phasor diagram, that's going to be, so this is going to be equal VAB. Right? So that's VAB points to VAN. That's always points to the first one. And if you move this VBN here, so therefore VAB actually lagging VAN by 30 degrees, right? So therefore I know this is going to be negative 30 and minus 30 degrees, because the VAN has negative 30 degrees. So the VAB is further lagging this by 30 degrees. You could use a calculator if you don't want to use a phasor diagram. And the magnitude of VAB is going to be square root 3 times the same deal we had for the positive sequence. So therefore I got a 277, negative 60 degrees. And VBC is equal VBN minus VCN. So then this one I have something like this. So this is VBC. And so therefore this is going to be equal, VBC is going to be lagging VBN by 30 degrees. Right? I can move this phasor parallel to the origin here. So therefore you see this VBC is going to be lagging VBN by 30 degrees. And so I have VBN is 90 degrees, so I got the 60 degrees. I got a 277 square root 3, got a 60 degrees. Or VBC is leading VAB by 120 degrees, right? So this has negative 60 and this has positive 60 degrees. And VCA is going to be equal to VCN minus VAN. This one actually easy, right? So this is VCN minus V, and so this is the VCA, and so this is going to be 277 square root 3 and 180 degrees. Or you could write negative 277 times square root 3. That's the same. Or you can write negative 180. Doesn't really matter, right? The negative 180 and the positive 180 the same. So these are the for the negative sequence. And you see how things can be simplified if you use a phasor diagram, right? No calculator involved, right? So I hope you all can get yourself familiar with this very simple but very useful tool. And the phasor diagram is really useful in terms in the future. Some of you take 320, right, and some of you take 423. Those are always very useful in terms of the phasor diagram. Okay, so that's all I want to cover in this lecture. And remember, no matter what you do, and keep it going, right? So we are very close to the end of the semester. 2 more lectures to go. I'll see you next time.